Hello, so let's get started with the further discussion about the free fall. So here is one activity that is the try this. Take a small stone, hold it in your hand. Which forces are acting on the stone? Now release the stone. What do you observe? What are the forces acting on the stone after you release it? So these are all the questions which are asked here in the try this activity. We are going to see the answers to these questions in the further part. So we know that the force of the gravity due to the earth acts on each and every object. When we were holding the stone in our hand, the stone was experiencing this force, but it was balanced by a force that we were applying on it in the opposite direction. As a result, the stone remained at the rest. Once we release the stone from our hands, the only force that acts on it is the gravitational force of the earth, and the stone falls down under its influence. So, whenever an object moves under the influence of the force of gravity alone, it is said to be in the state of the falling freely. Thus, the release stone is in the free fall. So, the activity which we have given here, that we are supposed to take one stone in our hand, and we have to think about that which forces are acting on that stone. So the one force which is acting, that means as we are holding the stone in our hand, so the force is acting, that is the muscular force, as we are holding the stone, and the other force which is acting on the stone, that is the gravitational force. And once we release the stone from our hands, so the only force that acts on an object, that is the gravitational force of the earth, and due to which the stone falls under onto the ground under the influence of the gravitational force. So whenever an object moves under the influence of the force of gravity alone, it is said to be in the falling freely. Thus the release stone is in the free fall. In free fall, the initial velocity of the object is zero. As initially we are holding the stone in our hand, so the initial velocity, that is u, is equals to 0 meter per second. As the object is at the rest position, as we are holding the stone in our hand, and goes on increasing due to the acceleration due to gravity of the earth. So the velocity will goes on the increasing as the acceleration due to gravity is acting on the stone. So during free fall, the frictional force due to the air opposes the motion of the object, and a beyond force also acts on the object. Thus, true free fall is possible only in the vacuum. तो सबसे पहले यहाँ पर बोला गया है कि ड्यूरिंग द फ्री फॉल द फ्रिक्शनल फोर्स ड्यू टू द एयर अपोजेस द मोशन, यानी जो एयर होती है वो एज अ फ्रिक्शन का काम यहाँ पर करती है. सो इट ट्राइज टू अपोज द वेलोसिटी एंड इट्स ट्राइज टू रिड्यूस द वेलोसिटी ऑफ द ऑब्जेक्ट. But the beyond force also acts on that object. So the force of the buoyancy, as we have studied in the class 9 about the Archimedes principle, that when an object is partially or fully immersed in a fluid, a force of buoyancy acts on it in the upward direction. And this force is the weight displaced by that object. So there also the beyond force, that is the force which is acting on an object in the upward direction. That means we can say here that the force which is exerted on that object due to the air, that means it is opposing the motion of the object from falling the down to the ground. So the force of the buoyancy, that means the beyond force is also acting on the object which opposes the motion of the object. Thus true free fall is only possible in the vacuum, as we are considering the vacuum situation, and if we release the object in the vacuum, so the only force we can assume here that the object will be in the true free fall, as there is the no air present in that chamber which will oppose the motion of the particular object. So, for a freely falling object, the velocity on reaching the ground, that is the earth, and the time taken for it can be calculated using the Newton's equation of motion. For free fall, the initial velocity u is equals to 0 and the acceleration a is equals to g, as we are considering here the situation of the free fall, and the only force which is acting on the object is the gravitational force of the earth. So here we are going to consider the acceleration a, which is equals to g, that is the acceleration due to gravity. Thus, we can write the equations as, तो equation कैसे होंगे, v is equals to gt, as we are having the Newton's first equation, V is equals to U plus AT. Here the initial velocity is U is equals to 0. So V is equals to, and A is the acceleration due to gravity, that is G. So the first equation, V is equals to GT. Second equation of the Newton's second law of motion states that S is equals to ut plus half gt square. As u is 0, so ut, that product will 0, and S is equals to half gt square will remain. So we are having S is equals to half gt square as the second equation for the free fall. And third equation, v square is equals to u square plus 2as. So v square is equals to 2gs as initial velocity is 0. So for calculating the motion of an object thrown upwards, acceleration is negative. सपोज अगर हमने एक ऑब्जेक्ट को ऊपर के डायरेक्शन पे फेंका, सो द एक्सेलरेशन ड्यू टू ग्रेविटी इज एक्टिंग ऑन द डाउनवर्ड डायरेक्शन. दैट मीन्स इट इज इन द अपोजिट डायरेक्शन ऑफ द मोशन ऑफ द ऑब्जेक्ट. सो द एक्सेलरेशन ड्यू टू ग्रेविटी विल बी हियर नेगेटिव. That is in the direction opposite to the velocity and is time taken to be minus g. The magnitude of the g is same, but the velocity of the object decreases because of this negative acceleration. The moon and the artificial satellites are moving only under the influence of the gravitational field of the Earth. Thus, they are always in the state of the free fall. Do you know the value of the g is the same for all the objects at a given place on the Earth? Thus, any two objects, irrespective of their masses or any other properties, when dropped from the same height and falling freely, will reach the Earth at the same time. So Galileo is said to have performed an experiment around 1590 in the Italian city of the Pisa. He dropped two spheres of the different masses from the leaning tower of the Pisa to demonstrate that both spheres reached the ground at the same time. So Galileo has performed an experiment in the 1590 in the Italian city of the Pisa. So he dropped the two spherical objects of the different masses from the leaning tower of the Pisa, and he tried to find out that whether they both the object of the different masses reach the ground at the same time or not. So when we drop a feather and a heavy stone at the same time from the height, they do not reach the earth at the same time. The feather experiences a buoyant force and a frictional force due to the air, and therefore floats and reaches the ground slowly, later than the heavy stone. The buoyant and the frictional forces on the stone are much less than the weight of the stone and does not affect the speed of the stone much. Recently, scientists performed this experiment in vacuum and showed that the feather and the stone indeed reach the earth at the same time. So, if we throw two objects of the different masses, so here the two objects has taken, that is the light weather feather, and the other one is the heavy stone. And if we are dropping the both the lightweight feather and the heavy stone at the same time from the particular same location, so as we experiencing that both are reaching to the ground at the different time. This is because the force of the buoyancy that is acting on the object, that is the feather, is much higher as compared to the heavy stone. So the heavy stone reaches to the ground at the before time as compared to with the feather. So and in the recently time, scientists have performed this experiment in the vacuum. So if we are neglecting that is the air condition, and we are performing the same experiment in the vacuum as there is a no presence of the air. So as we can see that the feather and the stone will reach at the same time on the surface of the earth. So here is the link which we can see and watch the video related to with that experiment. So here we are having two solved examples. So let's see. An iron ball of the mass 3 kg is released from the height of the 125 meter. So जब भी एग्जाम्पल ऐसे न्यूमेरिकल पूछे जाते हैं तो सबसे पहले वी हैव टू फाइंड द गिवन एंड टू फाइंड. सो गिवन हियर इज द मास ऑफ द आयरन बॉल दैट इज द 3 kg एंड हाइट यहाँ पर हमें दी है 125 मीटर एंड फॉल्स फ्रीली टू द ग्राउंड. दैट मीन्स दिस इज द केस ऑफ द फ्री फॉल विच इज आस्किंग द क्वेश्चन. Assuming that the value of the g, that is the acceleration due to gravity, is 10 meter per second square, that is the acceleration due to gravity is also given in this numerical. सो कैलकुलेट क्या करना है, तो सबसे पहले टाइम टेकन बाय द बॉल टू रीच द ग्राउंड, एंड सेकेंड वी हैव टू फाइंड द वेलोसिटी ऑफ द बॉल ऑन रीचिंग द ग्राउंड, एंड थर्ड द हाइट ऑफ द बॉल एट द हाफ द टाइम इट टेक्स to the reach the ground. So firstly we have to find the time taken by the ball to reach the ground. So यहाँ पर मास दिया है, हाइट दी है, acceleration due to gravity दी है. So as we are having the three equation which we have derived with the help of the Newton's equation of the motion. So which equation will be suitable as we are having the mass, height, that means the s, and velocity v, acceleration due to gravity g. So as we can use the Newton's second equation, S is equals to half gt square for this free fall motion to calculate the time t. So after substituting all the values, that is the height 125 meter, then mass and all. So we are getting here the time t is equals to 5 seconds. So the ball takes 5 seconds to reach the ground. So second, we have to calculate the velocity of the ball on reaching the ground. So velocity, that is the final velocity which we have to calculate. So we have to again think at which equation will be suitable. So we are having the time with us now and the acceleration due to gravity. So we can use the first free fall motion equation, that is v is equals to gt. So after substituting the values, we are getting the final velocity of the ball, that is 50 meter per second. So the velocity of the ball on reaching the ground is 50 meter per second. Then we have to calculate the height of the ball at half the time it takes to reach the ground. So we have to consider, we have to find the height of the ball at the half the time. That means t by 2. So t we have calculated, that is the 5 seconds. So after dividing it with the 2, we are getting the time 2.5 seconds. So we have to find the ball height at this time s. So s is equals to ut plus half at square, that will be the gt square. So s is equals to initial velocity 0, half multiplied by t, as we are having the time that half time 2.5 second. So 2.5 whole square, that will be the, we are getting here the height 31.25 meter. Thus the height of the ball at the half time. So we have to subtract it from the total height. So total height 125 meter as we have given in the question. And we are subtracting that 31.25 meter from this. We are getting that the height of the ball is 93.75 meter. So now let's see the example 2. A tennis ball is thrown up and reaches a height of the 4.05 meter before coming down. What was its initial velocity? How much total time will it take to come down? Assume that value of the g we have given. तो सबसे पहले दिया क्या गया है, यहाँ पर हमें हाइट दी गई है, एक्सेलरेशन ड्यू टू ग्रेविटी की वैल्यू हमारे पास है, एंड वी हैव टू फाइंड द इनिशियल वेलोसिटी एंड हाउ मच टोटल टाइम इट विल टेक टू कम डाउन. यानी total time we have to calculate of the tennis ball to reach to the ground. So for the upward motion of the ball, final velocity, that means the at after throwing the ball in the upward direction, so the final velocity will become the 0. So distance traveled by the ball we have given, at that the ball is reaching at the height of the 4.05 meter, and acceleration, as we have seen in the theory of the free fall, that when an object is thrown in the vertical upward direction, so the acceleration due to gravity acts on it in the downward direction. That means the negative direction motion. So we are here taking that negative acceleration, that is minus g. So here we will get that a is equals to minus g, that is minus 10 meter per second square. Using Newton's third equation of the motion, as we have seen here that v square is equals to 2gs. So after putting the values of final velocity will be 0, u square, that is initial velocity we have to calculate, and 2 multiplied by here minus 10, that is the acceleration due to gravity, and we are having the s value given 4.05 meter. So initial velocity will be 9 meter per second. So the initial velocity of the ball is 9 meter per second. Now let us consider the downward motion of the ball. Suppose the ball takes t seconds to come down. Now the initial velocity of the ball is 0, u is equals to 0. Distance traveled by the ball on reaching the ground, that will be the same distance, as we have seen that the distance will be the same as the ball reaches up to the height of the distances, that is 4.05 meter. And as the velocity and the acceleration are in the same direction, so here the acceleration due to gravity value will be positive acceleration, that is 10 meter per second. So according to the Newton's second equation of the motion, we will able to calculate the time t which the ball will take to reach to the ground. So After substituting values, s value we are having initial velocity 0, half acceleration due to gravity that will be the 10, and t square t value which we have to calculate. So t square will be here 0.81 and t will be after taking the square root it will be 0.9 second. So the ball will take 0.9 second to reach the ground. It will take the same time to go up. Thus, the total time will be taken will be two twice of 0.9 second. So we are having here the time that is 1.8 second. So now let's see. Here we are having use your brain power. So according to the Newton's law of gravitation, Earth's gravitational force is higher on an object of larger mass. Why doesn't that object fall down with a higher velocity as compared to the object with lower mass? So here we are having the answer to this question in the gravitational potential energy part. So let's see what is the gravitational potential energy. We have studied potential energy in the last standard. So as we are having, as we know, firstly, what is the energy? That is the energy which an object gets when the object is in the motion, or the energy which is stored in the object. So we are having the two types of the energy, that is the potential energy and the kinetic energy. So potential energy is the energy which an object has due to its specific state or the position. And the kinetic energy is the an energy which an object gets when the object is in the state of the motion. So potential energy एग्जाम्पल हम देख सकते हैं कि जो डैम जो होते हैं तो डैम में वाटर जो स्टोर किया जाता है सो एज द डैम द वाटर इज stored in the dam with the proper surface so the energy which is stored in the dam that water is having the potential energy and when the water from the dam is released the potential energy will get converted to the kinetic energy. So we have studied potential energy in the last standard. The energy stored in an object because of its position or the state is called as potential energy. This energy is relative and increases as we go to the greater heights from the surface of the earth. We had assumed that the potential energy of an object of mass m at a height h from the ground is mgh and on the ground it is 0. So when h is small compared to the radius r of the earth, we can assume g to be constant and can use the formula mgh. So mgh जो formula है जो हमने lower classes में derive किया था for the potential energy. So when to use this formula as h is small compared to the radius of the earth when the height जो हमारे पास जो height है अगर वो radius of the earth के comparison में बहुत छोटी होगी तो then that at that moment we can use the formula for the potential energy that is mgh. But for the larger values of the h the value of the g decreases with increase in the h. So as the height will increase so the value of the g decreases as we have seen that the effect of the gravitational acceleration due to gravity with respect to the height. So as we have seen above that as the height increases, so the acceleration due to gravity will decrease. So here we have seen in this chart that height increasing with the kilometer, so acceleration due to gravity becomes decreases. So but for the larger values of the h, the value of the g decreases with increase in h. So for an object at infinite distance from the earth, the value of g is 0 and earth's gravitational force does not act on the object. So it is more appropriate to assume the value of the potential energy to be 0 there. Thus for the smaller distances that is height, the potential energy is less than 0. That means it is negative. When an object is at the height h from the surface of the earth, its potential energy is minus gmm upon r plus h. So we have to remember this that when an object is at the height h from the surface of the earth, so it will have the potential energy as the minus gmm upon r plus h. Here m and r are the earth's mass and radius. As we have, I have told earlier that we have to remember the mass and the radius. So the mass of the earth is 6 into 10 raised to 24 kg and radius of the earth is that 6.4 into 10 raised to 6 meter. So escape velocity. सो अब तक हमने देख लिया ग्रेविटेशनल पोटेंशियल एनर्जी एंड फ्री फॉल के बारे में. So now let's move with the concept of the escape velocity. So क्या है escape velocity? We have seen that when a ball is thrown upward, its velocity decreases because of the gravitation of the earth acting on that object. The velocity becomes zero after reaching a certain height. And after that, ball starts falling down. Its maximum height depends on its initial velocity. So according to the Newton's third equation of the motion, that is v square is equal to u square plus 2as. So the final velocity of the ball will become zero as the ball reaches at the particular height, and acceleration will be negative, that is a is equals to minus g. So we will have the formula, we will have the equation as 0 is equals to u square plus 2 into minus g into s, and the maximum height we can calculate here, that is the s value, that will be s is equals to minus u square upon 2g. So thus higher the initial velocity u, the larger is the height reached by the ball. सो ये क्या यहाँ पर जो ये स्टेटमेंट बताया जा रहा है, तो ये क्या है कि अगर जैसे ही हम इनिशियल वेलोसिटी ऑफ एन ऑब्जेक्ट जो हम बढ़ाते जाएंगे, तो हाइट ऑफ दैट ऑब्जेक्ट टू रीच will also increases, as we can see here in the formula that s is directly proportional to the u square. That means initial velocity increases, then the height will also increases. So the reason for this is that higher the initial velocity, the ball will oppose the gravity of the earth. More and larger will be the height to which it can reach. We have seen above that the value of the g keeps decreasing as we go higher above the surface of the earth. Thus the force pulling the ball downward decreases as the ball goes up. If we keep increasing the initial velocity of the ball, it will reach larger and larger heights, and above a particular value of initial velocity of the ball is able to overcome the downward pull by the earth and can escape the earth forever and will not fall back on the earth's surface. So, अगर हम initial velocity of that ball of any object, if we go on keep it increasing, सो हमने इतनी बढ़ा दी कि अभी वो जो ऑब्जेक्ट है, जो बॉल है, वो कभी रिटर्न वापस मतलब अर्थ सरफेस पे आ ही नहीं सकता. सो दैट वेलोसिटी विल एंड इट विल बी द एस्केप फ्रॉम द अर्थ फॉर एवर. So that velocity we are calling as the escape velocity, and we can determine its value by using the law of conservation of energy as follows. So law of conservation of energy, as we have studied in the ninth class, that is, it states that energy can neither be created nor be destroyed. It can be converted into the one form of the energy to the another form of the energy. So, an object going vertically upwards from the surface of the earth, having an initial velocity equal to the escape velocity, escapes the gravitational force of the earth. The force of gravity being inversely proportional to the square of the distance, as we have seen above that the Newton's inverse square law, which derived that force is inversely proportional to the 1 upon r square. So becomes zero only at the infinite distance from the earth. This means that for the object to be free from the gravity of the earth, it has to reach infinite distance from the earth. That is, the object will come to the rest at infinite distance and will stay there. So how we can calculate the escape velocity for the object? So for an object of the mass m on the surface of the earth, kinetic energy will be half mv square. As we know that height we can calculate for the short distance as compared to the earth radius. So we can use here the formula as half mv square. So potential energy, as we have seen above, that will be the minus gmm upon r. So the total energy, as we know, that total energy is kinetic energy plus potential energy. So we are adding these both two energies. So half mv square escape minus gmm upon r. So this will be the total energy. And at infinite distance from the earth, kinetic energy will become zero, as the final velocity is, as we are taking at finite infinite distance, it will be the zero. So half m into zero square. That means the kinetic energy of the object at infinite distance from the earth will become zero. Next, the potential energy, that is minus gmm upon r. So here r, that means the radius of the earth as we are taking. So it will be the infinite as the object is escaping from the surface of the earth. So here the r value will be infinite, as anything divided by infinity will give zero. And total energy which we can calculate here, that is the kinetic energy plus potential energy. So the total energy will be zero here. From the principle of the conservation of energy, E1 is equals to E2. That means the half mv escape square minus gmm upon r is equals to 0. So as we are using here the principle of conservation of energy, that means we are equating both the E1 and the E2. So V escape square is equals to 2gm upon R. So V escape is equals to under root of 2gm upon R. V is equals to, as we have seen above, that gm upon R. So here we are getting that 2gr. So how this 2gr has came, as we have seen above, that the value of the small acceleration due to gravity, we have derived one formula, that is g is equals to gm upon r square. So after putting the value of the g is equals to gm upon r square, we are getting here the value as under root of 2gr. And after putting the value, that 2 multiplied by g value, as we know, that 9.8, and the radius of the earth, that is 6.4 into 10 raised to 6. So after putting all these values and taking under root, we are getting that escape velocity will be 11.2 kilometer per second. So the spacecrafts which are sent to the moon or other planets have to have their initial velocity larger than the escape velocity, so that they can overcome Earth's gravitational attraction and can travel to these objects. So जो सैटेलाइट्स और जो स्पेसक्राफ्ट्स अर्थ सरफेस से जो स्पेस में भेजे जाते हैं, सो दे आर हैविंग द इनिशियल वेलोसिटी जो होती है, तो वो 11.2 किलोमीटर पर सेकेंड से ज्यादा होनी चाहिए, so that they can escape the gravitational force of the earth and can escape from the earth's gravitational force and can enter into the space. So here we are having one solved example, that calculate the escape velocity on the surface of the moon given the mass and radius of the moon to be 7.34 into 10 raised to 22 kg and 1.74 into 10 raised to 6 meter respectively. So we are having the formula V escape is equals to under root of 2gm upon r. So after putting the values as universal gravitational constant value, we are having 6.67 into 10 raised to minus 11 Newton meter square per kg square. So after putting all these values in the equation, V escape is equals to under root of 2gm upon r. We will get the escape velocity as 2.37 kilometer per second. So escape velocity on the moon will be 2.37 kilometer per second. So next we are having, do you know, weightlessness in the space? So space travelers as well as the objects in the spacecraft appear to be floating. Why does this happen? Though the spacecraft is at the height from the surface of the Earth, the value of the g there is not zero. In the space station, the value of the g is only 11% less than its value on the surface of the Earth. Thus, the height of the spacecraft is not the reason for their weightlessness. Their weightlessness is caused by their being in the state of the free fall. Though the spacecraft is not falling on the Earth because of its velocity along the orbit, the only force acting on it is the gravitational force of the Earth, and therefore it is in the free fall. As the velocity of the free fall does not depend on the properties of an object, the velocity of the free fall is the same for the spacecraft, the travelers, and the objects in the craft. Thus, if a traveler releases an object from her hand, it will remain stationary with respect to her and will appear to be weightlessness. So, weightlessness is the concept which is for which it is given in this. Do you know? So the space travelers which are going with in the spacecraft, that they appear to be floating. So as the what was the reason behind that floatingness? How they experience the weightlessness in the spacecraft? So this is because of the we can see here that they are in the state of the free fall. So as we have seen that there is no only no force acting on that uh, the persons which are moving to the space in the spacecraft. So due to which they are not experiencing the any kind of the force acting on them. So due to which they experience the weightlessness in the space.